I want to go out, but it's so hot today.
Why don't you take an umbrella with you? It will protect you from the sun.
That's a good idea.
Susan, do you know how an umbrella helps you to protect against the hot sunlight on a sunny day like this?
Well, it blocks the sun's rays from reaching me.
How come the rays don't bend around the umbrella to reach you?
Not sure.
Light can't bend around objects. Light always travels in a straight line. The direction of light can only be changed through reflection. Want to find out more? Stay with us.
In this lesson, you will learn about the reflection of light from plane mirrors. At the end of this lesson, you will be able to demonstrate that the path of light is always a straight line. Explain reflection of light from plane mirrors. And identify the characteristics of an image formed by a plane mirror.
Let me show you some common examples that prove light travels in straight lines. Here, I'll switch on a torch. See? The light goes in a straight path to incident on the wall. It does not bend anywhere.
Hey, it's suddenly become nice and cloudy. Looks like it will rain.
Yes. Notice how the sun's rays are filtering through the clouds. You can clearly see the light in straight lines here.
Oh, yes, you're right. I can clearly distinguish the straight lines of light.
Can you think of any instances where you noticed light traveling in straight lines?
How about the red beam of light emitted by the laser toy gun my little brother plays with?
That's a good example.
Hey, what's this, Miss Sunshine?
What happened, Susan?
You had said that light travels in straight lines. Then, how is this beam of light coming back from the mirror?
Oh, that is because any shiny or polished surface, such as a mirror, changes the direction of light incident on it. Remember I told you the direction of light could be changed by reflecting it? Just like the beam of light incident on the mirror of the dressing table, let's direct the red beam of light from your brother's toy gun to incident on the mirror. Do you see what happens to the beam?
Oh, yes. It changed direction, just like the beam I noticed earlier.
This happens because light incident on any smooth surface, like a mirror, bounces back into the same medium. This bouncing of light by any smooth surface, like a mirror, is called reflection of light. Notice another thing. Though light changed its direction when it was reflected from the mirror, it still travels in straight lines only. The path of light is never a curve. It is always a straight line.
In addition to the beam of light, I can see myself in the mirror as well.
Of course. That's what happens when you stand in front of a plain mirror. It is because of the light from your body reflecting from the mirror. Your reflection in the mirror is called your image.
So, the mirror will reflect an image of anything that is placed in front of it?
Rather than telling you, let me show you. let's get that vase from the table there. Now, we'll place this plain mirror vertically on the table. Place the vase in front of the mirror, please. Can you see the vase in the mirror?
Yes.
That's the image of the vase in the mirror. Thus, in general, the impression of an object carried over and formed by light in a mirror is called the image of the object. In this case, the real vase in front of the mirror is the object.
My image seems to be becoming smaller as I move away from the mirror.
That's natural. As your distance from the mirror increases, the distance of the image from the mirror also increases.
Really?
Well, it can be proven easily. Let us place a scale perpendicular to the plane of the mirror on the table. The scale will help to measure the distance of the object in front of the mirror and also the distance of the image behind the mirror. Now, remove the vase and place a dice in front of the mirror. This will serve as the object in this activity. Move the dice closer to the mirror now.
Done. Now what?
Look at the image of the dice. What happened to the image when you moved the dice closer to the mirror?
Oh, you're right. I can tell from the reading on the scale that the image is now closer to the mirror.
That's right. And if you move the dice away from the mirror, the reverse will happen. The image of the dice will move away from the mirror by the same distance.
So, basically, the distance of the image behind the mirror is always equal to the distance of the object in front of it, right?
That's absolutely correct, Susan. So, if you are standing at a distance of 1 meter in front of the mirror, then your image will be behind the mirror, at a distance of 1 meter from it.
Wow! So my image is at a distance of 2 meters from me when I'm just a meter in front of the mirror?
Right. Smart thinking.
Did you know? The fact that images in a mirror are located at the same distance behind the mirror as the object in front of it is widely used in architecture and interior decoration to make rooms appear bigger and brighter. When a mirror is placed along a wall, the room gets reflected in it. As the image is located behind the mirror at a certain distance, the room appears to be nearly twice its real size. Moreover, placing mirrors near lights, chandeliers, and table lamps helps to reflect the light over a larger area and make the surroundings appear brighter. Reflection in plain mirrors can also be used to have a lot of fun. Have you ever been to a mirror maze? A mirror maze is created using the principle of reflection in plain mirrors. This maze has several plain mirrors placed at fixed angles to each other. Whenever a person enters the mirror maze, he sees several images of himself and several passages in front of him. However, only one passage is real, while all the rest are just images. So a person ends up bumping into mirrors trying to find his way out.
Now let's play a small game based on reflection of light. Try to read what is written on Susan's t-shirt. A bit difficult, isn't it? Can you guess why? This is because what you just saw was Susan's image reflected in a plain mirror. And the words that you saw on Susan's t-shirt were left, right, invest. Here, when you look at Susan directly, you can see that the message on the t-shirt is, "My name is Susan."
But what did you mean by left, right, inversed?
Left, right, invest means that the image shows your right to appear as the left and the left to appear as the right. To give you another example, stand in front of the mirror and look at the hand on which you're wearing your wristwatch. Which hand are you wearing it on?
The left hand.
And which hand does it look like in the mirror?
It looks like I'm wearing it on the right hand. I see what you mean now.
Did you know ambulance is written left to right inversed on an ambulance, so that when the driver in a vehicle ahead looks into his rear-view mirror, he can make out the word ambulance quickly and give way.
So, did you happen to notice any other characteristics of your image in the plane mirror?
Let's see. My image reflected in the plane mirror is left, right, inversed. But it looks exactly like me.
Is it erect or inverted?
Erect, of course. And I guess it is the same size as me.
Absolutely right, Susan. There is one last important characteristic of plane mirrors that I want to show you.
Oh! What's that?
Remember the activity with the vase that we performed earlier? Let's set up that activity again. Place a white cardboard behind the mirror where the image appears. Let's see if we can capture the image on it.
We don't see the image on the screen. Let me try by placing the cardboard in front of the mirror. Still not getting the image on the screen.
That's right. We are not able to capture the image of the vase formed by a plane mirror on a screen. Images that cannot be captured on a screen are known as virtual images. So, you see, Susan, the image formed by a plane mirror is of the same size as that of the object. Left, right, inversed. Erect. Formed behind the mirror. Formed at the same distance behind the mirror as the distance of the object in front of the mirror. And virtual.
Did you know? Based on the characteristics of an image formed by a plane mirror, it has been found out that the minimum length of a plane mirror required for someone to view their entire image is half their height. You'll learn why that happens in higher classes. This brings us to the end of the lesson on reflection of light. In this lesson, you learn to demonstrate that the path of light is always a straight line. Explain the reflection of light from plane mirrors. And identify the characteristics of an image formed by a plane mirror.